2020 organized by Triple IT Kanchipuram, India, and was one of the finalists for the Indian National Academy of the Engineering Innovation Student Project Award 2021. His two recent research papers are picked by the IEEE Communication Society for the best reading for OTFS and delayed Doppler signal processing. His student's paper was one of the finalists for the Best Student Paper Award at the IEEE SPCOM ISC Bangalore in India, July 2022. He is co-founder and director of Multi-Suite Network Private Limited and a startup in the 5G wireless communication domain. His current research interests lie in the area of embedded system design for 5G and beyond wireless system, including FPGA-based hardware design, 3GPP compliant firmware design, private 5G and test bed setup. His research interests also include transceiver design for 5G and beyond wireless system, including parameter estimation, orthogonal time frequency space, and ML application for 5G and beyond wireless system design. He is currently working as an assistant professor at Triple IT Bangalore. Now, I would like to request Dr. Prem Singh Sir for start the second session of FDP on the topic receiver design for high mobility beyond the 5G wireless communication. Please, sir.
Thank you for the introduction. So, how many minutes before the lunch break do I have? Just 10 to 15. Okay. Maybe I can stand here because the screen is not coming here. So anyway, my introduction is done. So before starting, my presentation is having two parts. One is being from wireless communication community, we do a lot of research where we have liberty to achieve many things. Many times we assume, okay, our system model is working under this assumption. If we are not getting results, we assume, okay, let us assume this, if we are getting results. But when you build practical wireless system, okay, so there is no scope of any assumption when you build practical wireless system. So I'll talk about the work we are doing at IIIT Bangalore, building practical wireless system. You can say product-based project, where the outcome of the project eventually will go to market. And at the later part of the talk, I will talk about my theoretical research. So these are the projects I am currently handling at IIIT Bangalore. So the first three projects, 1, 2, 3, you can say they are completely product-based. There is no research component involved as such. It is building practical system. And last two are completely research oriented. Okay, so this is my team at IIIT Bangalore. As of now, I see some around, its number is now slightly more than 12. If I'm not wrong, it is around 15 people, and research engineer postdocs are working with me on these projects. And just an announcement, we are still looking for good student for postdoc, PhD and masters. In case any of you is interested, please feel free to mail me. We can discuss. So this is the table of content. As I said, I will be briefly going through the embedded system design for 5G. It is typically the work which we are doing in our lab. And then the second part will be the receiver design for high mobility beyond 5G wireless communication. That is the core research part. Okay, so now let me start with the first work. So it's a brief overview only. DU accelerator card. So So now let me try to connect this. We all use mobile phone, right? Mobile phone, we know there is a base station. So when you say mobile phone, or in wireless terminology we call it as cellular network. So cellular network has three components. One is user, which you can see at the bottom, which is your mobile phone. You have radio access network, which connects your mobile phone to the base station, that tower. And then you have core network. Core network means which connects you to the rest of the world. Like if you want to access internet, you want to mail to someone else, so that is the part of core network. So when you see the current deployment, the 4G, and now in many of the cities we have 5G also. So the current deployment is based on this technology. When I say this is a traditional radio access network, the intelligence which is sitting at the base station, I am not talking about the structure of the tower, I am talking about the intelligence sitting at the tower. So there is, you can imagine there is one box, and that box is coming from big players like Nokia, Siemens, some of the Chinese company. And so now because of that, all the current deployment of 5G and 4G, we have been procuring, not only India, other countries also have been procuring these radio access networks from these companies only. So there is only 4 or 5 vendors. So now to break this monopoly, there is a I would say the hot topic in the industry, that is called Open RAN. Open RAN is Open Radio Access Network. So the idea is, instead of using one box, let us break that box into smaller box. So let's say this is a traditional network. You break that into smaller network or boxes like the CU, I think this is CU, which is called central unit, DU is called distributed unit, and then you have RU called radio unit. So the obvious question is, what is the advantage of this? It is very challenging to make this complete box because the capex is very high. The cost involved is very high. But since now this has been broken into smaller boxes, even small vendors or even a startup can come up and make these boxes. And when I say Open RAN, Open Radio Access Network, the interfaces between these small intelligent boxes, they are open and standardized. It's like, imagine a desktop some 10-15 years back, when you are buying, when we used to buy a desktop from Dell, we used to have mouse from Dell, keyboard from Dell, everything from Dell, right? Now in today's time, you can have monitor from Dell, you can have keyboard from HP. So what has happened? Because the interface is now standard. Interfaces are standard, so they are compatible with each other. So same sort of setup is being tried in communication industry. Now in our lab, we are designing this distributed unit. We are designing the hardware of this, and we are designing the software which runs on that hardware. So this is an FPGA based card. So that intelligence box, when I say that intelligent is divided into 3 layers, L1, L2, L3. We all know that where L1 is the lower layer, is the physical layer, L2 is RLC and MAC, and L3 is PDCP and RC. So when I say distributed unit, I mean is we are designing this part, which consists of a physical layer and lower part of L2. So this physical layer, it is a very computationally intensive layer. So it cannot run on any general purpose processor. It requires very high computational power, which typically provided by FPGA. So for DU card, we are designing an FPGA based accelerator card which will run this hi-fi, and there is a server which will run this lower end. So in short, we are going to have this setup. So this is the complete DU. This is the accelerator card which will sit inside this server. This accelerator card will run the physical layer. This server will run the L2 layer, and this will connect to the RU on this side and this side to the C. So this is the work we are doing in our lab. So you guys, this is the top view of the accelerator card. So I'm not sure whether any of you is from VLSI domain or not. It's a 16-layer PCB. This is highly complex. So now you can see all the interfaces on this card. This is PCI. So if there is a PCI slot in the server, you just insert this card in that server, and that server is hosting the L2 processing, and this card is hosting physical layer processing. In that way, your distributed unit will design. And since we are following ORN, Open Radio Access Network, someone else can design the other boxes, means other the CU and DU, and then we can plug and play because the interfaces are now standardized. One thing? Okay.
Next time.
So we start.